Welcome to Gyan Niketan channel. I am Dr. Harendra Kumar Sinha. I am going to describe the mathematics for class 12. The topic is here relation. That is relation on a set. On a set. What do we mean by the term relation on a set? That the relation we write in this form, R is a relation defined on the set A to A. Its meaning is this R will be a subset of A cross A. We know the Cartesian product of the two sets. For an example, consider an element 1, 2, 3, and then we write A cross A, and this will be consisted of the ordered pairs in which the two elements both will be from the set A because it is A cross A. So it will be like 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So this is A cross A. Any subset of A cross A will be a relation on the set A to A. So as many subsets are possible, that many different kinds of relation we can define from the set A to A. For an example, suppose I am writing one relation, name it R1, that is 1, 1 and 2, 3. The two ordered pairs, the two elements here are from A cross A, that is 1, 1 is here and 2, 3 is from here. So this R1 is a subset of A cross A. It is a subset of A cross A. So this is the relation defined on the set A to A. So in this way, as many different subsets we can have of A cross A, that many different kinds of relations we can define from the set A to set A. So we know that if a set contains n elements, suppose the number of elements in a set A is equal to n, then the number of possible subsets is 2 to the power n. According to that, here in this we are having the 9 elements. So how many subsets are possible? 2 to the power 9 subsets are possible. 2 to the power 9. That is 512. 512 different types of relations we can have on the set A to A. So as many subsets are here, that many different kinds of relations we can define from the set A to A. Here I have taken just an example, but how we write? We write the relation under certain given criteria, that R is a relation defined on the set A to A, such that, I am giving one example related to it, such that AB belongs to R if and only if A plus B is equal to 6. So this is the criteria, how the elements will be related, that if A is A plus B is equal to 6. In this relation R will be the set of ordered pair in which, from this example, the sum of the two should be equal to 6. We find the sum, if there be any, only one element is here, that is 3 and 3. So this is the relation. So in this way, different criteria, different conditions will be given to us. According to that, we take out the ordered pairs from here and we make the relation. Another example I am taking, let R is a relation, another one, R is a relation defined on the set A to A, such that AB belongs to R, implies that and implied by. That is if and only if A is smaller than B. Now I have to take that all ordered pairs all such ordered pairs in which the first member is smaller than the second member. The first member is smaller than second member. As here it is 1, 2. It is 1, 3. Then we have 2, 3. 2, 3. 2, 3. So only 3 members are here. So in this way, we can define, we can obtain the relations from one set to another set. Certain criteria will be given. Under that criteria, we take out the ordered pairs from A cross A to write down the relation. We know that what we have already studied in our class 11, that the set of first element is its domain and the set of the second element is its range. So here, for this relation, the domain is the domain of this relation. You see, the domain of this relation is the set consisted of the element 1 and 2 only, and the range is the set of the second element, that is 2 and 3. That is 2 and 3. So this is its domain and this is range. Here also I can write the domain is 3 and the range is 3. Here, for this example, the domain is set having the element 3 and range is also the same. Range is this one. Now the very important thing to know that the different types of relations, different types of relations on the set A, means from A to A. The first is the reflexive relation. The very first is reflexive relation. Reflexive relation. Let R be a relation if for all A belonging to A, I am writing the relation R from the set A to A only. So reflexive relation, if for all A belonging to A is related to A, that is AA belongs to R, then this R is reflexive. Means each element should be having related with the same one itself. A is related to A, then AA belongs to R, and that relation will be a reflexive relation. The example is here. Let A is the set 1, 2, 3, and then we write A cross A. I am writing the relation, a subset of A cross A, 1, 1, 2, 2, 3, 3, 3, 3, 1, 2, 2, 1. This example, what we find that the doublets of each element is present here. So this relation is the reflexive relation. For all elements belonging to the set, the elements are here 1, 2 and 3. So 1, 1 is here, 2, 2 is here, and 3, 3 is here. So all doublets are present in the relation. So such relation is the reflexive relation. This relation is an example of a reflexive relation, right? Reflexive relation. And the second is symmetric relation. Symmetric relation. That relation is a symmetric relation in which if AB belongs to R, A is related to B, then B must be related to A. So we write in short that if AB belongs to R, implies that and implied by BA also belongs to R, then this R is a symmetric relation. The above example is sufficient to describe the symmetry. Because 1 1, the reverse is 1 1, 2 2, the reverse is 2 2, 3 3, the reverse is 3 3, that all are here. 1 2, its reverse is 2 1, that is here. 2 1, its reverse is 1 2. So every element AB is having BA in the same relation. So this relation is symmetric as well. And the third is the transitive relation. Transitive relation. Transitive relation. So in this relation, if AB belongs to R, that is A is related to B, and B is related to C, BC belongs to R, BC belongs to R, this implies that AC also belongs to R. Then this R is a transitive relation. Transitive relation. Transitive relation. This example is sufficient to show for the transitivity of the relation, that here you see 1 1, what we have to observe AB and BC. You see this, so the two are the same, the two should be the same, and the result should be AC, must be present in the relation. You see 1 1 is here, 1 2 is here, so the 1 2 must be here, that is already here. 1 2 2 1, so 1 1 must be here, that is here. So this relation is reflexive, symmetric as well as transitive. So such relation which is reflexive, symmetric and transitive is known as an equivalence relation. Thus a relation which is reflexive, symmetric and transitive is known as an equivalence relation. So this is a very suitable example for the equivalence relation. This relation is reflexive, symmetric as well as transitive. So this much is for today, and we shall meet in the next video. Thank you.